What? Hello there. Hi, 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 hi. Weird. That, I believe, is Mount Rainier. Is that right? It's when I was going to Seattle, I think. I'm going to finish up breakfast. Let's see how this looks. Ba 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 ba. Ba 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 ba. Ba 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 ba. So happy this is being recorded. You can never remember. I don't know. I can never remember song lyrics. Yeah, that's nice. You can never remember. It's just gonna be me. I'm the only one here. Do, 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 do. Oh, look at that. It's over there now. That's kind of awesome. Good morning. Yeah, my full undivided attention for right now if you have any questions. Okay. So Adrenaline, if you can hear me, uh, if you have any questions, just ask away. You can ask on chat, or you can just hang out until I get things started officially. Oh, what happened? There we go. Okay. Good morning, Lantana. If you have any questions, ask away. Otherwise, just hang out until things get started. All right, Madison and Tana. If anybody has any questions, feel free to ask. Otherwise, just hang out until we start 7:45. I lost somebody. No, no. All right. Antana made it back. Okay, good. Do, 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 do. Yes. Yes, Madison is. There we go. Quincy's here. So again, if anybody has any questions about anything, feel free to ask. We're not going to start for another 10 minutes. This is sort of like office hours right now, so feel free to use them. Oh, you're connecting. Okay. I don't know what that means. See who just came in. Tomorrow. Okay. Oh, good. Yay. Can everybody else? This is going to be funny for me to ask. Can everybody else hear me? Yes. Yes. I got one yes, two yeses. Ooh. I got a yes, yes in chat. Ooh, I like how you guys are just like, let's put our answers everywhere. And then Madison. Yes, Madison said yes. Let me see. Damara doesn't want to play. There we go. Okay. All right. We got about 7 more minutes, everybody. So again, if you have questions, ask away. Otherwise, just sit there. Man, still haven't got the lighting figured out. Hi, Jeff. towels. Oh, well, too bad. All right, so you are just not going to work here. Nothing's going to fall over. All right, stay there. See if that's better. Ah. Oh man, lighting is going to be the end of me. Let me see. All right. Ouch. Good morning. All right. Do 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 do. All right. It's kind of crazy. Oh well. Let's see what that's like. Mm. Mm. Oh, it's still there. It's amazing. All right, I'm gonna figure this out. I really am. All right, it's right at the edge. Okay. Okay, I can live with that maybe. Let's see. That's got to be exciting. Watching lighting get set up. Okay, let's see. Anybody get the section 8183 handout I put up on Canvas? If not, you might want to go get it right now. If anybody's, let's see, one person's out there still. Okay, Nantana, you got it. Thank you. Anybody else get the section 8183 handout from Canvas? 2 people. Okay. Man, I'm looking kind of rough. I'm just letting this go. So we're almost ready. Oh, 3 people. Yay. If you have not gotten the A1A3 handout from Canvas, go to Canvas and get it. We're going to talk about it today. We're going to talk about it. All right. 4 people. Ooh, somebody just came in. What's that? Richard, there we go. Okay. Oh, I wonder, did I get your, oh well, I guess I'll find out. What time we got? 2 minutes. 2 minutes. And how many people do I have today? 1, 2, 3, 4, 5, 6, 7, 8. If I get 4 more people, that'll be an all-time high. Oh my God. If you just joined us, have you gotten the Section 8183 handout from Canvas yet? If not, go get it. That's a huge thing we're going to be working on today. I think I got my lighting in a decent place. Let me test it out. See if any of my markers will work today. It's time to start. Here I am with 1, 2, 4, 6, 8. All right. So you're sort of working. How are you working? You look pretty good. All right, sweet. Maybe I should use you. All right, guys. So before anybody else, I don't know. We'll see if anybody else shows up. Anybody have questions? Have you started chapter 8? That might be a little much. Actually, let's start off with this. Anybody have questions? Anybody have questions from 4 and 7, chapter 4 and 7, because that's what today's quiz is going to be on. An acceptable question would be, what the hell was chapter 4 and 7? I can at least remind you what they were. Nope. Okay. Well, all right. So chapter 4 was remember chapter 4, so the quiz. Chapter 4 was the x, p of x stuff. Remember the x, p of x stuff, right? Chapter 4. And then it was the binomial stuff. N choose x, p to the x, q to the n minus x. That kind of business, right? That's chapter 4. And then chapter 7 was where we started doing this thing. Remember that? Down there? There it is. Let me see. This would help me out a lot. Give me a minute. How do I... There we go. Make sure I just didn't screw you guys up. Everything looks the same, right? You guys can read this, I guess. No, somebody says no. What's the no for? What did I say that somebody's saying no? I'm saying no now too. What's happening? Anybody have questions on chapter 4 and chapter 7? Because that's what the quiz today is on. Oh, is that what you had? You said no because you don't have any questions? I don't know. Maybe that's what you meant. This is still weird, talking to my laptop basically, but you know, these things happen. Okay, so the quiz today, one more time, is chapter 4, chapter 7. The formulas are on the quiz. So take the quiz just like you would in the classroom. You don't have phone, you don't have computer, you don't have anything. Can I quickly go over chapter 7? Hold on. Sure. So if you're just joining us, real quick reminder, today's quiz, chapter 4, chapter 7, it was the xp of x stuff and the central limits theorem, the chicken, lettuce, tomato stuff. Somebody has a wonderful question, very specific. Can you go over chapter 7? So this is what we're going to be doing. If you haven't gotten this handout yet from Canvas, go get it right now. We're going to be doing that eventually. Chapter 7, let me see how well this one works. Ooh. Chapter 7 would have a problem like this. we know the mean of something is 17, and the standard deviation is 2.5. Cool. Oh, there's somebody. Hey. So I'm doing a quick example from chapter 7. So they give me the mean and the standard deviation for some population, right? I don't even know if it's normal. But then they tell me I take a sample of 78 items from this group, okay? And then they ask me, what's the probability that the sample mean is less than 18? Coolness. So this is fundamentally what every problem in chapter 7 does. They might have a first part where they tell you it's normal and you take one person or one thing. That's what we did in chapter 6. The new thing in chapter 7 is if I take a sample and I ask about the sample mean, then I have to know what all the sample means look like. Can anybody tell me what the distribution looks like for this problem? It looks like a butterfly. Yes, it looks normal. It's normally distributed. Now, somebody else tell me, how did Isaiah know that it's normally distributed? Because he's special. No, come on. How do we know? Yeah, the sample size is more than 30. Okay, so hopefully, I am really hoping right now that most of you guys should be like, oh my God, yes, it's greater than 30, Jeff. Holy shit. It really should sort of be like that right now. No matter what the distribution looked like at first, if I take a sample greater than 30, the means will be approximately normally distributed. So what do I need to do first before I start to do what I need for this problem? What do I need to figure out before I do anything, any work? What's the very first thing I need to do? Run away screaming. No. Yes. So I've got to figure out the new standard deviation. This is really the only thing, to be honest, the only thing that's like different, which seems insane because we did a lot of discussion. We had alternate universe Florida. We had all this other shit. And then the only thing that ends up happening is this. But that's kind of big. So it's the old one divided by the square root of the sample size. Now I get people put all kinds of shit in here. I don't know why. It's the standard deviation divided by the square root of n. That's what it is. Everybody understand that this symbol right here, this symbol right here is a single symbol. It isn't sigma divided by x or some weird shit. It is sigma sub x bar. It's the standard deviation of the sample means. So it's one symbol. So what the hell is that? Let me see. I have my calculator right here. 2.5 divided by square root of 70. Holy shit, what did I push? Okay, I've never seen that before. That's neat. But yes, 0.283, I'll say 283 because I'm lazy. And that's as far as I have to go is 3 decimal places. You can go more decimal places. I don't mind. All right, and then you can draw the picture. I know it's normally distributed. I know the mean is the same. Here's my 18 up here. I want to have this area. I make a z-score. I look it up in the chart. So I always want to balance out. I hope it gets to a point where it's easy because it's the same thing, but don't ever forget why it works. I know it's normally distributed, so I know how much area is where. The chart kind of tells me how much area is where, and the area is the probability. We went over all that in chapter 5. So we got a lot of little parts that all come together for this problem, making it relatively simple. So if I make a z-score out of 18, 18 minus the mean divided by the new standard deviation, you get about 3 point, I don't know. What, anybody? What do you get? What in tarnation? 100 divided by 28, 50 divided by 14, 25 divided by 7 is 3.5. I don't know, 3 point. Nobody's going to help me out. Oh, 3.53. Thank you. All right, so I'm sorry, you guys can't see it. This is a chapter 7 example problem because it's going to be on the quiz today. Chapter 7 stuff. So I'm given a mean and standard deviation. I have no idea what the original thing looks like. It could be uniform, it could be binomial, it could be who cares? Because my sample size is big enough. Therefore, I know it becomes normally distributed. So I calculate my new spread. I make a z-score like we did before. I look that z-score up in the chart. Some of you guys might remember, if you look that up, you're going to get officially in the chart 0.9999, or I'd say approximately 100%, because it's off the chart, but you can put 0.999. All right, any questions on that? I mean, this is really the only new thing between chapter 6 and chapter 7. Is that cool? Anything else? Any other questions? Chapter 4, chapter 7. Can you go over chapter 7, 65? All right, let me see. Pull up the book here. Talk amongst yourselves. Come here. No, I don't want that one. A good teacher would have had the book shut. Let's see. All right. So what'd you say? Chapter 7, 65E. This sounds familiar. All right. 7. Homework. 65. Okay, this is one about, oh yeah. Okay. Was it the other class I went over this with, or this class? This is the one about the songs in somebody's iTunes collection, right? It might have been the other class. I don't know. So let's see. Even if you don't have this, I don't care. You have it because it's being recorded. See, bye-bye. Bye-bye, problem. So number, what was it? 65, part E. I love it. Let's do part D first. Let's talk about it. I'm going to do it because it's your work. Ain't mine. I got enough work. They give you a uniform. So given a uniform distribution from 2 to 3.5, right? This is number 65E, number 65 on chapter 7. They give you this. You know the mean is that plus that divided by 2, which is something. 2.75, I think. Let me stop for a minute. So this is number 65. They give me a uniform distribution, right? Now, just to make sure, if you guys are wondering, why the hell am I calculating the mean of this? Because part D wants to know what the sample means do. And I know I took a sample of 43 songs, right? So I need to know the mean and the standard deviation for the sample means. So what that means is I've got to know what the original mean and standard deviation were for the uniform thing, and then I can do my special magic using that sample size. But I got to know what the hell. So the problem we just did, the example I just had up here, I gave you a mean and a standard deviation. We could do the magic. We could do divided by square root of n right away. This one, they gave me a uniform curve, and they said, here you go. Haha. So we got to calculate our own mean and standard deviation before I can do anything, of course. I'm not saying that's going to be immediately obvious, but what goes here and here are the mean and the standard deviation of these. And in order to find that, I've got to know what the mean and the standard deviation were in the first place. So I know the mean is this, and it stays the same. What kind of distribution will it be? What kind of distribution will the means follow? Yeah, even though it was a uniform curve to begin with, I don't care. N's greater than 30. I know it's going to be normal. Now, the standard deviation was whatever the shit that is. I don't know what that is. I have no idea what that is. I don't even want to try to guess. Nobody's going to help me. All right. You're like, come on, math boy. All right. Leave me alone. Yeah, I get 433. Thank you. So for this problem, you might have some issues with, it never told me to do this. It never told me to do this. But it asked me to figure out what samples of 43 will do. If I knew the mean and the standard deviation of the original, I could then figure out those. So of course I'm going to do this. So what's the standard deviation for my groups of 43 sample means? Let me say that again. Took a group of 43. What do my sample means follow? What standard deviation will they have? It's not going to be this. What do I have to do to this to figure out what standard deviation they have? Same thing we do every night, Pinky. Try to take over the world. No, you divide by, right? What's the new standard deviation? The old one? Divided by square root of sample size. That's all I'm going to do in that one. I'm tired of that one. Okay. Anything else about that problem or other problems? In case you joined us after I said this a few times, don't forget a quiz is going to be put up on Canvas, made active right after the lecture. It's going to be due tonight, just like before. The formulas are on the quiz. Treat it like you would a quiz in class. If you, I don't know, want to be smart, you will do that because then you'll get an accurate feeling for what you actually have in your head. So the final, you might be more prepared for. All right, enough of that. Sorry. Let me think what else I was going to say. Oh, go to Canvas right now and get the section 8183 handout if you haven't done that yet. We're about to get into it. All right. Anything else from chapter 4 or chapter 7? Because that's what the quiz is on today. Man, I'm not used to having so much here. Did I tell you guys this is going to be my co-beard 19? Co-beard 19? No? Okay. It's kind of dumb. I don't care. I get a laugh out of it. Nothing else? Okay. So we're going to get back into chapter 8. I'm going to talk a little bit about the idea, even though I went over it extensively in the last video from last week. My gird. Well, let's see. All right, I'm gonna have to clean it off in a minute. So just to remind you guys, chapter 8, we took a really kind of long time. We talked about dolphins and shit. So if you like dolphins and you missed the last, am I still here? Okay. Am I like freaking out? I love my internet connection. It is so awesome. I'm sure you guys can agree. All right. Let me know if I get blurry or if I get something, you know. All right. You know what I'm talking about. All right. Let me see. Let me get myself over there. So we did, hopefully, we did a lot of work. I did, but hopefully we all went through it together to get to, now remember, we all know this formula right here. We all know that formula right there. And what we did was we used the basic idea behind that formula, and we said, okay, we normally don't know the mean. We normally know just the sample mean. We don't know the population mean, right? You work really well for a minute marker, and then you just give up. Come on, you're good right now. Oh man, these things you can't get high. And what we want to do is we want to go up and down from that guess. So basically, when we take a sample mean, it is our best guess for the actual population mean. We actually talked about that then on day one. Day one, we talked about that, right? So we all know this. So what a confidence interval does is it tries to go one step beyond that. It tries to improve on that guess, right? On that estimate. It says, all right, let me start with my sample mean, and then give or take so many standard deviations. Now, of course, if I have a sample mean, I must have taken a sample. And since I'm talking about the sample means, I've got to change my standard deviation. So really, that's it. That's the formula for confidence intervals. It's the same formula I have here. It's just, oh shit, I don't know that. Let me use my guess. Oh, to get the guess, I had to take a sample. Okay, I got to change the standard deviation. Am I getting kind of wobbly, or is that just me? Oh shit. Is my internet doing all right, guys? Or is it just my screen? I don't know. Can somebody tell me, is my internet okay? It looks like it's okay now. I love it. This is so awesome. And nobody, oh, thanks. Thank you. Thank you. Sort of. Okay. Let's all hope. Let's all hope. Please. Okay. Google Fiber, save me. Where the hell are you? All right. Okay. So let's do a problem. Let's try a problem out. Actually, wait a minute. Let's do this. No. Screw this. Let's do this problem. All right. So let's say I take a sample of 50 people, and I find an average, an average number of days that they've been sheltering in place. Because some states still aren't doing that because they're stupid. What's 30 about? I'm not moving at all. Okay. Jesus. All right, please, connection, please. Let's see, we have an average of, what you got, Jeff? 15.2 days that they've been sheltering in place, right? And we know the standard deviation for all people sheltering in place is 3.81. All right. So of course, this is just a process example. This is not actual data. Let me see. This pen is dying already. So I want to find, okay, you're going to work for a while, aren't you? Okay. Find the 90% confidence interval. All right. I look shaky on my end. Now I'm stuck. Come on, please. Please, connection. All right, nobody's complaining yet. So I guess maybe it's just on my side. So what's the only thing in this equation, in this formula that that the problem didn't tell me directly? I know X bar, I know sigma, I know N. So the only thing it didn't tell me directly is Z. What part of the problem must relate to Z? Of course, it's the other piece of information, right? The 90% confidence. Okay. So the fundamental idea behind this is almost scarily simple. Is that a word? I just made it. Scarily? Eerily? Eerily is a word. All right. If I go out a certain distance from the middle, I will catch a certain amount of stuff. If I catch a certain amount of stuff, I'm that confident that I caught a certain thing. So if I start at the mean that I found, oh man, see, you're giving up already. If I start at the mean that I found, and I go up and down a certain number of steps, then I will be that confident, the percentage I catch. If I catch 90% of the data, I will be 90% confident that I caught a particular thing. And what is that particular thing? The real mean. I don't know what the real population mean is. I just have a guess. Okay. So how do I catch 90% of the data? Why am I allowed to use z-scores here, by the way? Very good question. I'm sorry. I'm really choppy on my side, but if it's still good for you guys, okay. Why am I allowed to use z-scores here? Good. And now somebody else tell me, why do we know it's normally distributed? Is anybody else out there? Is it just me and Livia? I see a bunch of names here. Yes. That's true, Rudy. We don't know the real mean, but the whole purpose of what we're doing is to get a better feel for what the real mean might be. The whole reason that we do this is to have a better feel. So if somebody came up to you and said, I'm 90% confident that you're going to make between a 90 and a 94 on the next test. Does that make you feel pretty good? I mean, if this guy's wearing a tinfoil hat and, and no pants, I might be. But if this was a statistician, works for the government, he's like, he had analyzed your data and he said, I feel 90% confident that you're going to make between a 90 and a 94 on the next test. Would that make you feel good? Wow. Some of you guys are like, yeah, I just want a B. I don't want an A. That would be interesting. If that same person came to you and said, I am 90% confident that you're going to make somewhere between a 50 and a 100 on the next test. Does that do anything for you? So, I love it. Just like any statistics, we will sometimes do this process and come up with something that doesn't mean shit, because sometimes that's life. Sometimes we just don't know enough. We don't have enough information. But that's why we do it. If I do end up with a confidence interval like 90 to 94 and I'm 90% confident that the real mean is in there, that tells me something. I can work with that, right? So then we do work with it. And the ones that I can't work with, guess what? We go get more data. We go get more information. Then we try to make a confidence interval. And once we have more information, to get a better feel for what things are. I like it. So, so can somebody tell me, so here's the 90% confidence interval. Is that cool? Let me say this right now, because this is going to come up later. We might as well talk about this right now. I love it, because I always forget to talk about it, and then it suddenly shows up. This is going to sound weird at first. Let's see. How many tails did I just make when I drew that picture? How many tails did I make? Yes. Everybody cool with that? I made 2 tails, right? 1, 2. How much area is in each tail? Careful, Madison. Went one step too far. If there's 90 in here, there's 10% total, which means there's 5% in one tail. Is that cool? So there is a symbol that will come up very soon that looks like a fish. It's the Greek letter alpha. Alpha is the amount of area in the tails. So for a 90% confidence, alpha is 0.10. It's 10%. 90% inside, 10% outside. Is that difficult? No. So that's the Greek letter alpha. Little fish dude, which is nice because it's related to tails. Fish have tails. All right. Sorry. So can you just take a minute? Now this is what that symbol means. That's nice. But to actually figure out what the z-scores are, I have to use that area, of course, right? Because the chart only understands areas that are below a given z-score. So don't say anything. Don't type anything. Just look that up on the chart, and then I'll ask you in a minute what you got, and then I'll show you a shortcut. This is going to look very familiar. It's going to be that little asterisk dude. All right, what did you guys get? Anybody get what that z-score is going to be? No, I'm a fish. I tell you, yes. Oh, I know you're all experiencing the same level of stir craziness I am, but I'll try to get through. Sorry, I'm going to be extra goofy sometimes. So that is right. And of course, is everybody cool with the fact? Oh shit, I've frozen. Am I okay? Is everybody cool with the fact that if that's negative 1645, that has to be positive 1645 because of symmetry, right? It's symmetric. Boogie, woogie, woogie. Okay, maybe. And notice this. Do you see how there's a negative one and a positive one? Because there's two sides to this thing. And do you see how there's a plus and minus built into the formula? So what number do I put in for z? 1.645. The plus and minus is built in. It's built in. So the really nice thing about this formula is this is what it looks like in algebraic formula format, and this is what it looks like graphically, visually. Those two things are the same thing. So here's what the work looks like now. Now we have the last piece that we didn't know. Let me see which marker is currently working. Come on. So if I do this, x bar, 15.2, give or take, 1.645 steps. Oh shit, I'm gonna go onto my actual wall here in a minute. 3.81 divided by the square root of 50. I did not plan out my space well, sorry. You guys can't really see that, can you? So 15.2, give or take 1.645, up and down, 1.645 steps. And of course, the steps are going to be 3.81 divided by the square root of 50 because I took a sample of 50. Okay, maybe. And then like last time I suggested, oh man. Let's see if this one works. Okay, you're working for right now. Do this piece first. Who remembers what this piece was called? What was that piece called over there? It was called Frank. No, it wasn't called Frank. Cold coffee. No? Anybody remember what that was called? You know, like there's a whole weekend in between, man. No, I appreciate that. Alpha is the area in the tail. That piece of the formula is called the error. Error, Will Robinson. So it's kind of makes sense. The mean is our best guess. Give or take this much. So this is the amount that we think we're off by. That's why we call it the error. Error is a weird word if you say it a lot. Error. Sorry. So if you do this work, 1.645 times 3.81 divided by the square root of 50, you get 0.886. Make sure you can do that piece. And now you just do 15.2 minus that. Oh shit. And 15.2 plus that. So I get 14.3 up to 16.1. Generally, I try to have the same decimal points here as this had. Do you guys see what I'm saying? But if you go a couple more decimal places, whatever, that's fine. Just don't round too much. have at least the same number of decimal points that this guy had. Yep. All right. Is that a decent interval? If somebody said it's between 14.3 and 16.1, that sounds pretty good. If somebody said it's between 2 and 80, okay. So, but do you understand? Even if somebody said it's somewhere between 2 and 80, that is still information. That is information that we need more information. That is, I don't know enough yet to improve my estimate well. You know, then I'm immediately notified that I need to do more data collection. Okay, so here we go. We're going to look at that handout, and then I'm going to try to do some new stuff before I let you out of here, you know, or off here. I don't know. I don't know how to describe classes anymore. Okay, so I'm going to share my screen here in a minute. Everybody still write down? You guys all got that, hopefully? Let me see. What I have done, let me see if this works. Oh, crap. Okay. It's going to really be exciting here in a minute. All right. Here we go. Sharing my screen. Well, that's not. Oh. Do you guys see the section 8 one? Ah, shit. I can't see anything. There we go. Sorry, give me a second. I'm trying to figure out how to work with this now that I've shared my screen. Well, I can't see chat anymore, so if you're chatting with me, too damn bad. All right. Let me see. So hopefully you've printed this out for yourself. Let me do this. So let's see. How do I want to work this? Nah, screw it. I'm just going to do this because I can't even see what you guys are saying if you're saying anything. I got to play around with this more. I'm not sure how to still see chat when I... Here we go. Can I see chat? No, I can't. If I see you chat, I don't know where you are. Oh, well, everybody just sit back. Here we go. So on this first problem about dolphins again, I don't know, just go with it. Find their average length to be 92.6 inches. Dolphin lengths are known to be normally distributed. Come on now. Stop it. With a population standard deviation of 4.11 inches. All right. So we're curious about this, wherever we took the sample of dolphins from, we're curious if they happen to be longer or shorter than normal dolphins or something. So we're going to make a confidence interval to get a better feel for our guess. All right, let me talk about it. So we can see, I'm told all these things. I'm told what X bar is, right? So I'm told that X bar is 92.6. Let me see how good this works. All right. This is my little grading tool. I like it. Okay. Because I can draw and type. Thank the gods. I'm also told that the standard deviation is 4.11. And of course, I'm told that N is 37. Not 378 there. Therefore, why is it okay to use z-scores here? Because, and again, if you're answering this on chat, I can't see chat. Why is it okay? Because N is greater than 30. And that means central limit theorem says go for it. All right. I like it. So now let me see if I can draw. Here we go. This is going to be exciting for everybody. I want to make a 95%. Oh, crappity doodah. 95. There it is. 95% confidence interval. Come on, you could do it. There you go, buddy. All right. So which means if I draw this in here, this will be, this is exciting. This is why I wish I had a Surface book or something, but too bad, Jeff. All right, I'm gonna do this. You actually could have you could have, Jeff, you could have. Just deal with me. Come on, screen. There we go. All right, so I know that there's 0.95. There we go, buddy. There's 0.95 in there, which means that below this one, no, just stop it. Below this one, there must be 2.5%. Is that cool? Let me put this, I don't know where to put that. Too bad, right? Let me stop for a minute. I can't even, I can't see everybody. I can't see chat. I got to figure that out. I don't know that about Zoom, how I can share and see chat. I don't know, it just won't let me. Man, it won't even let me do anything. Let me see. I'm going to do a little bit more and then I'm going to stop sharing and see if anybody has a question. So if I look up 0.025 in the chart, 0.025, I get exactly 1.96. I don't care about the positive, negative, because it's built into the formula. I get 1.96. Okay, so let me stop sharing here for a second. Let me see. Oh, here we go. I can see chat. All right, I can see chat. Anybody have a question? Okay. Not seeing any chat questions coming through unless somebody's typing a book. I'm going to keep going. Okay. So now I just got to fill things in, right? So now I know X bar. So using the formula, I know that X bar is 92.6, give or take. Right, you're gonna have to forgive that. Give or take 1.96 times the old standard deviation divided by the square root. Well, that's gonna suck about type. Oh, too bad. You just deal with it, everybody. We can't make a square root symbol, so. All right, that's nice. All right, there you go. Come on, we can do it. So then I get 92.6, give or take. So if I do that error piece, I get 1.96 times 4.11 divided by the square root of 37. I get 1.32. Let's say 1.324. All right, let me see if I can get chat back. I got chat back. Any questions so far? Whoa, shit. Nothing yet. Okay. And then, of course, you just take 92.6 minus that and 92.6 plus that and round it and wait for the screen to wake up. There we go, screen. And I get 91.3 up to 93.9. All right. Now, of course, the thing I didn't do earlier was the part that I know you're all going to love the most, is the conclusion. So we are, get in there. We are 95% confident that the interval uh, 91.3 inches, don't forget units, to, get over there, today, get back over there, okay, to 93.9 inches contains the true population mean length of dolphins. Bam. All right, let me check in. Let me see. Where's my chat? Damn it. Where's my chat? There it is. I don't see anything. No questions. Interesting. Not sure how to take that. All right. Hopefully this is not that bad. This is actually, there's no piece of this. All the parts are old. All the parts are stuff we've done before. Some of it is stuff we've done a lot. Oh, Monica, what you got?
So pretty much the larger the interval is that, wait, hold on. Trying to process this. So this means that we're 95% sure that the mean is between those two intervals, right?
And this is going to sound really picky,
Uh-huh.
but the way you just said it is wrong.
Okay. See, I'm trying
because
to, that's why.
the mean exists before I do anything.
Okay.
And then I make my interval.
Okay.
So either my interval catches the mean or it doesn't catch the mean,
Mm-hmm.
right? I don't put an interval down and then the mean falls into it or not.
Oh,
I don't know
okay.
if that makes any sense right now, but that's why it sounds like I'm getting picky with the words, but it's important. So we are 95% confident that our interval we just made contains the real mean.
Okay.
So we feel like there's a 5% chance that our interval doesn't contain the real mean.
There's a 5% chance that our interval doesn't contain it. Okay.
Yes.
And in general, does it matter? Like, do you want like the smaller the interval, is that better? Or meaning like, you know, the numbers in between, is it better to have like a smaller interval, or does that not matter?
Always. Okay. Now I want you guys to realize I could make the interval smaller in a couple of good ways. Like if I made n bigger, do you guys see, looking at the formula, if I made n bigger, then the error would get smaller. Is everybody cool with that?
Yeah.
You don't have to raise your hand or anything, but let me know if you're not cool with that. Mathematically, if I make the denominator big, the whole thing gets small.
Mm-hmm.
So it makes sense. We've known that since day one. I'm all choppy again, but oh well. We've known that since day one. A larger sample is good, right? And this is actually mathematically showing us interface. Hey, look, math agrees with you. A bad way to make the interval small is to make our confidence small. Now stay with me, guys. If I wanted to make a 90%, look at part B actually. Look at part B. You should be able to answer the question before you do any work. And that's why I ask this question first. Would the 90% interval be larger or smaller than the one we just calculated? This is a 95% confidence interval because we constructed it to catch 95% of the stuff. If I make a 90% confidence interval, am I catching more or less stuff? Less stuff, right? 95% confidence interval we made, I catch 95% of the stuff. That's why it's as wide as it is. 90% will have to be not as wide because I only catch 90%. So I can always make a really small interval no matter what the shit. But it's kind of like useless. If I make a 10% confidence, 10% confidence, what do you do? I don't care. So, oh, Madison, I know. I'm sorry. Hopefully my internet calms down. Poor little dude. I knew I should have rebooted it. Oh. Sorry, everybody. Well, let's see. So what I can do if my internet's getting all bad is I could make, let me see, we've done the first part. I can make a video handout because I don't want to give a lecture that some people can't even hear. That would suck. How is it right now? Is it okay? Anybody? Matt, is it still bad? Is that? Try something. We got 10 minutes. Let me try something. I'm probably gonna lose you guys. So you might have to rejoin, okay? Let me try something. There's a chance I won't lose you. Just if you get disconnected, just get back in. All right, here we go. I'm gonna try. All right, am I back? Are you guys still with me? Holy shit. There we go. Is it better? Better, you think? Let me try. Is that better? All right, I'm gonna go with this being a little bit better. Okay, coming back to the sheet here. Okay, so I can't hear you. Damn it! It's gonna take a fix then. So let me do this. I'll finish this up. I'm gonna type something real quick. I'll finish this up in a video. We still need to discuss how to do this, right? People are already leaving. I love it. Now watch this. Is it? No, it's still bad, isn't it? Okay. Oh, now it's good. Now it's good. Is it really good right now? Yes, of course it's good now. Now that I've lost a couple people I heard. All right. You think? Let me just stick to that plan. I don't want people to have just left and then they miss something. I'll post the rest of this handout. I might do a little bit of a preview. Can everybody still hear me okay? Oh, it's good now. I know. That's the wonders of technology. It's still really choppy. Some people, okay. So I'll post the video. I will include a preview of section 8.3. Remember, for those of you who can hear me, I'll say this. Remember 8.2, we will come back and do after 8.3 because 8.2 uses a different distribution. A different distribution? Yeah, uses a different how do you spell it, damn word? Distribution. So I like to do 8.3 before 8.2 because 8.3 still uses the z-score distribution. Okay, that is all for today. I will remember to reboot my internet next time. Okay. Yes. Quiz is due 11:59 p.m. tonight. I will go make it active in a minute. All right. Anyone have hijabi? No. Anyone have questions? Okay. 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 Let me go diagnose. Yes, formulas are on the quiz. Yes, formulas on quiz. I must go diagnose my Wi-Fi before my 9 a.m. meeting. Bye, everybody. Mm-hmm.